Example the third. Determine whether the series n equals 1 to infinity of 1 over 2 plus 3 to the n converges or diverges. Okay, so notice again that the terms in this sequence here are positive. Check. Okay, and then also if you mentally do the nth term test for divergence, 1 on top, this is exponential getting exponentially large, 1 divided by infinity. This is going to go to 0, so nothing there. Okay, I don't know. I promise you that is going to come in handy at some point, just not on this one. Okay, so the last couple of examples, we were comparing to P series. What do you think we're going to compare to this time? So look at our dominant terms right here, and we have 3 to the n on the bottom. So this looks like it is going to be compared to 1 over 3 to the n, or if you prefer, 1/3 to the nth power here, and it's this series, n equals 1 to infinity. Yeah, we can start at 1 or we can start at 0 on this one, but since we, because geometric series ordinarily start at 0. Anyway, this one starts at 1, so we're going to start ours at 1. What do we know about this geometric series right here? Well, since r is less than 1, or actually I should say the absolute value of r is less than 1, since it's equal to 1/3, this is a convergent geometric series. I'm about to say G series. We got a P series and a G series. Convergent. No, try that again. Convergent G series. Don't write that on your test. Come on. They're gonna put you in a pile composed of Mr. Noel's students and just burn them all. Anyway, so yeah, this is a convergent geometric series, and we need to be smaller. So let's see if we can establish that inequality, folks. So 1 over 2 plus 3 to the n, is this less than or equal to 1 over 3 to the n? Well, of course it is. This is a bigger denominator than this one over here, so you divide by a larger number, it's going to be overall smaller. Okay, right? But, if you wanted to cross multiply, you totally can. I'd have 3 to the n on the left side is less than or equal to 2 plus 3 to the n. If that's not good enough for you, subtract your 3 to the n's from both sides. 0 is less than or equal to 2. That's always true. So if it's like for all n, right, we only need it to be greater than or equal to 1. So yeah, we're totally good to go there. So let's draw our conclusion, shall we? Since 0 is less than 1 over 2 plus 3 to the n, which is less than or equal to 1 over 3 to the n, for n greater than or equal to 1, and the sum from n equals 1 to infinity of 1 over 3 to the n is a convergent G series. I'm just kidding. Geometric series. And I'm going to say r is equal to, r is equal to 1/3 here, right? Just cover my bases just in case. Then our conclusion is that our series must also converge. So the series n equals 1 to infinity, 1 over 2 plus 3 to the n also converges by the direct comparison test. All right, I'll put it. By the direct comparison test. And once again, I'll just reiterate this. If you left that part off, you'd still be in good shape because you have met all of the criteria for the test. All right, so tell my geometry students the same exact thing whenever they're writing their 2-column proofs. You remember those fondly, don't you? That is, if you don't remember the name of the thing, just apply it, right? Whatever it is that the conditions are, just apply it and you're good to go. All right, so let's perhaps look at another one. Example, the fourth. Determine whether this series converges or diverges. And this one, again, looks geometric right here. And positive, well, yeah, we've got we're starting here at 1, and that's 2 minus 1 that's on the bottom. That's as small as that thing is ever, and it's the number 1, so this is always positive. So yeah, that's good. And then what do we want to check next? We want to check to make sure that the nth term goes down to 0, because if it doesn't, we're done. So let's say we take the limit as n goes to infinity of 3 to the n over 2 to the n minus 1. Hey, the top grows faster than the bottom. They're both exponential, but this is bigger than that one. Therefore, this thing goes to infinity, and this fails by the nth term test for divergence. So since the limit as n goes to infinity of 3 over n over 2 to the n minus 1 is equal to infinity, or I should say is not 0, then that series diverges. N equals 1 infinity, copy and paste over 2 to the n minus 1 diverges. And if you wanted to, you could say by the nth term test for divergence. So, okay, but let's just assume maybe in the heat of the moment again, because I keep saying the heat of the moment, but you know you're going to be taking this test in the gym, which is super, super cold. So in the cool of the moment, let's say you forgot to apply the nth term test for divergence, and so you're going to do a direct comparison test. You can still directly compare this to the series. What the heck is that? That's supposed to be an arrow. N equals 1 to infinity of 3 over 2 to the n. Whoops. What am I doing? There we go, right? So that's what this one looks like, and we're just subtracting 1 from the bottom there. And I know that this thing diverges, right? It's a divergent geometric series because this number, our common ratio here, r is equal to 3 over 2, which is greater than 1, so this is a divergent geometric series. Okay, so if you are divergent, you need to be bigger. Bigger than a divergent. So we're going to start with this 3 over 2 to the n, and we need to establish that that is smaller than ours, which is 3 to the n over, what is that, 2 to the n minus 1? Yeah, okay, 2 to the n minus 1. All right, and then over here on the left, I will just use property of exponents to make that 3 to the n over 2 to the n. Now, this denominator is slightly smaller than this. In other words, this one is a bigger denominator. Dividing by a slightly bigger denominator, it should be a smaller number. But okay, so again, in the cool of the moment, maybe you don't recognize that. So let's cross multiply here and get 3 to the n times 2 to the n minus 1 on the left should be less than or equal to, and on the other, 2 to the n times 3 to the n. And you know what we can totally do? Since these things are not 0 and they're not negative, we can go ahead and take out our cancellation crayon, which we haven't gotten to take out in a while. Cancel those things out, and I have 2 to the n minus 1 is less than or equal to 2 to the n. Well, isn't that true? I don't know. I just don't know. So cancellation crayon, again, I'll subtract that from both sides, and I get negative 1 is less than or equal to, when I subtract it, it should be 0. Is negative 1 less than or equal to 0? Yeah, it's pretty much true. For, well, that's supposed to be an F. For all in. Yep, there you go. All right, so you would just draw your conclusion at that point. And since we haven't drawn a conclusion about a divergent one, I'll go ahead and establish this one for you, even though, we proved it back up here with the nth term test for divergence, but whatever. Since 0 is less than, and we're going to start with our known series, which is 3 to the n over 2 to the n, or if you wanted to, you can write it like this guy right there, which is less than or equal to our 3 to the n over 2 to the n minus 1. So we're bigger than our divergent. We just need to say that it's divergent. And the sum, n equals 1, infinity 3 over n over 2 to the n is a divergent geometric series. So we've got to, let's just go ahead and say that our r is equal to 3/2. So they know that we know that this is a convergent geometric series because the common ratio is greater than 1. Okay, then our series, I think I was going to turn that into an and symbol. N equals 1 to infinity of 3 to the n over 2 to the n minus 1 also diverges by the direct comparison test. Hooray!